Okay, so question 1 has a triangle on the Cartesian plane. So if we drew a perpendicular down here, oops, I'll just do that in black. We get a right angle. And they've said that it's k and 1. So k is the x value. So you know that this here is k. And then the y value, this means that this is 1. So then we know that k, because of Pythag, is going to be, so k squared, because of Pythag, is going to be equal to 5 squared, or root 5 squared, minus 1 squared. And that's, you know, that's just Pythag.
Yeah.
And so then we get k squared is equal to, that is just 5 minus 1. So k squared equals 4. So then we know that k is equal to 2. Okay. So that's the first question. Now, this is obviously in different quadrants. So this is kind of like your cast diagram. So cos is positive, everything positive, sine positive, tan positive. Okay, so we can just think of our theta then as over here. I'll do it in pink. Because remember, this is the 180 minus theta quadrant. This is theta, this is 180 plus theta, and that's 360 minus theta. So if we see this as theta here, then we can think of this as being just 180 minus theta. And so this becomes our theta. And then it's simple, because now if we look at tan, tan is opposite over adjacent. So we've worked out that this is k is 2. So now we know our adjacent. So, and then we just look at what quadrant is it in, and then we know tan is negative in this quadrant. So tan theta equals opposite is 1, and adjacent is 2. But now it's minus a half, because it's in sine, only sine is positive in this quadrant.
Yeah.
So now we look at cos 180 plus theta. We see that that would be in the 180 plus theta quadrant. So cos 180 plus theta is equal to, again, cos would be adjacent over hypotenuse. So 2 over root 5. And in that quadrant, cos is negative, so we just say negative. Sometimes they want you to rationalize the denominator. They're not that strict these days, because they are looking for marks. But we can do that, and it's just a matter of saying then 5 and then negative 2 root 5. So this is rationalizing the denominator, meaning they don't want a third in the denominator.
Okay.
So this was 5.1.2, and this is A and B. And now C requires a little bit of work. So they want sine A theta plus 60 in the form A plus B over root 20. The first thing we're going to do is just look at sine theta plus 60. And we want to just convert that into something manageable. So we look for, on the right-hand side, you see that this is nice because this is sine A plus B.
Yeah.
So in this case, our theta will be A and our 60 will be B. So we can now write that. I'm going to do it in yellow. Sine theta plus 60 equals. And so let me just make the theta more obvious. Okay, so everywhere I see an A, I'm going to put a theta. So it'll be sine theta. And then when I see a B, I'm going to put 60 plus, and then cos A was theta and cos 60 degrees. Okay, so then sine theta is positive, so that's fine. So that's opposite over hypotenuse. So that's 1 over root 5. Then cos 60, we look at our special triangle. You see adjacent to the 60, which is 1 over, and then the hypotenuse for the special angle is 2, plus cos theta. So in this quadrant, it's negative, and we know cos is adjacent, which is 2 over root 5. And then finally, sine 60, we know is opposite. So that's going to be root 3 over 2. Okay, let's go back to white now that we've substituted it all in. And so we have 1 times 1 is 1 over root 5 times root 2 plus, this is root 5, wasn't it?
Yeah.
Root 5 times 2 over 2 root 3. Okay, and we see that these are both common. And 2 is the same as root 4. So there's 1 plus 2 root 3. Oh, one of these was negative, wasn't it? Because it's cos in the different quadrant. So our cos theta, that was negative root, because it's in, cos is negative in this quadrant. So this is actually a negative. Okay. This one here is a negative, because cos in this quadrant is negative, because only sine is positive. So we have 1 minus 2 root 3 over root 20. Okay, use a calculator to calculate the value of 2 theta plus 2 theta minus 40, correct to 1 decimal place. Well, you can just get the value of theta. Well, let's just get theta. So we know that tan theta equals minus a half, right?
Yeah.
So we can just get the angle of theta. What's the easiest one to do? The sine was the easiest one to do, because that's positive. We know that sine theta is equal to opposite which is 1 over root 5. So then just put in your calculator sine to the minus 1 of 1 over root 5. Put that into our calculator.
26.56.
What did you get?
26.56, so 26.6.
26.
Rounded up to.
Okay. So now just keep that answer and then say tan 2 times that, whatever you get. So tan 2 times answer, whatever that was, and then just minus 40 from that. And then that'll give you the answer.
Negative 38.66.
That's weird. If you do tan 2 times 26, something, you should get 52.
Very top.
So in your calculator, you're going to put tan, and then whatever that answer was, 26 point. Do you remember it to the nearest 2?
26.56.
Perfect, because we only need it to the nearest 1 decimal place. So we say tan 22 times 26,56, but then we keep it in the same brackets as the minus 40. So it's all...
Okay, then 0.233.
Perfect. So that's 0.2. Okay, cool. And then we want to prove the following identity. So I think that this one, we should maybe do, I'm just going to clear some space here. Okay. So they want us to prove cos x plus sine x. Okay, so what we're going to do is you usually need to do the left-hand side. So we're just going to get the left-hand side to look like that right-hand side. So we'll say LHS, and then we say cos x plus sine x over cos x minus sine x, and then okay, so what we can do is let's try and get it over the common denominator.
Okay.
Okay, so if we times these together, so if it was the common denominator, cos x minus sine x, and then we times by the other one. Okay, so this is our common denominator. So we've got the red here and the yellow here. So we're going to need to times this one. We times this one by the red, and we times this one by the yellow. Because you cross multiply in order to get a common denominator. Okay, so when we times this one, we get this one by the red. We get cos squared x plus, and then it's like the sine x times the sine x will be the sine squared x. And then when we'll get cos x times sine x will be sine x, and sine x times cos x will be cos x. So we'll end up with plus 2 sine x cos x.
Okay.
And then this one times this one will be, now this is a negative, cos squared x. And then it'll be, again, the same. So sine squared x times sine squared x will be, sine x times sine x will be minus, so times that. So it's minus, and then that'll be a plus sine squared x. And in the middle will be the cos x times the cos x will be minus sine x, and the sine x times the, so this will be minus 2 sine x cos x. Okay, so I'm gonna put that up there. Okay. And when we times the bottom, we'll just get cos squared x minus sine squared x. Because it's like a nice little difference of squares. Cos squared x minus sine squared x, and then the minus sine x cos x will cancel with the cos x sine x. So we get cos squared x minus sine squared x. Often you don't know where you're going with these, you just follow the kind of the rules that you normally need to do, which is that you get a common denominator. And hopefully it works out. When you get this cos squared x and this minus cos squared x, those go away. So let's see what goes away. Okay, those go away. The sine squared x's also go away, don't they? Because that's, when you times that by that, you get a positive. And then unfortunately these, so we get a minus 2 sine x cos x. This was a minus here. And so you're minusing a minus, which is a plus. So you end up with 4, the top 4 of these sine x cos x's.
Please.
Okay. We're wanting tan 2x. So basically what we're wanting is sine 2x over cos 2x and then a 2 somewhere. Well, we can take out our 2 now, because then at least we've got our 2 that we're looking for. We need this 2.
Yeah.
But let's take that out now. And so we end up with 2 sine x cos x. Which our double angle formula tells us that 2 sine x cos x is sine 2x. So that gives us our sine 2x. So we know we're going to be sorted on the top. So let's just look at the bottom. Cos squared x minus sine squared x. That's cos 2x over here. So we've got our full thing that we want. So now we just have to write it. So that was over, and then we found our cos 2x. So then we have 2 sine 2x over cos 2x, and that equals, now we can just say 2 tan 2x. And so then we know that LHS equals RHS. Okay, so with these, I know that a lot of students find these ones difficult because they don't know where to go, because from here to here, it's impossible to see it unless you're a genius. Be able to see the answer that is going to come to that. You know it's going to come to that because they tell you it will. But you need to just follow the steps that certain things that need to be done. So one of the things that need to be done is getting this common denominator. And especially if you see cos x minus sine x and cos x plus sine x, because the common denominator is going to usually end up with this something like this, or it could be cos squared x plus sine squared x, which is 1. So it goes away often. So what we do is we times the top, as we did here, we did the red times the top times the red, and then the yellows together, like that. And then it all worked out nicely. The other thing you need to do is often convert tans to coses. And then if you see a double angle formula and no double angle in the answer, convert all the double angle formulas into something reasonable on this side. Well, it looks unreasonable at the beginning, but then they start to cancel like this.
Yeah.
So we'll do a few more of those, I think.
No, definitely.
Practice.